Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn about a technique known as nodal analysis. Okay, so nodal analysis is basically used for analyzing various kinds of electrical circuits, and they are used to find the values of the node voltages. Okay, so node voltages of a electrical network. Okay, so nodal analysis basically uses the concept of KCL, Kirchhoff's current law, plus Ohm's law. Okay, so there are some rules to apply nodal analysis. Okay, so the first rule is we need to take a reference node. Okay, reference node. For example, let's say this is your node 1, this is your node 2. So we can assume this node as a reference node. Okay, so the voltage across a reference node is equal to 0 volts. Okay, so the next thing is we need to apply the concept of KCL at a particular node on which we need to find the value of the node voltage. Okay, so we need to apply KCL on various nodes. Okay, let's find the value of the node voltages V1 and V2 by using nodal analysis. Okay, so as you can see, on applying KCL at this node, we can say that, let's say this is your current I1. Okay, this is your I2 current, and this is your current I3, which is equal to 5 amperes. So we can say that on applying KCL at node 1, we can say that 10 ampere current source will be equal to I1 plus I2 plus 5 ampere current source. Okay, so the value of the I1, so it means that, so this implies the value of I1, so I1 will be equal to, let's say the voltage at this node 1 is your V1. So we can say that it will be equal to V1 upon 6. Similarly, let's say the voltage across this node is your V. Similarly, the voltage across this node is, let's say, your V2. Okay, so it means that the value of the I2 will be equal to V1 minus V2 upon 4 plus 5. Okay, so on simplifying this equation, we are getting 5V1 minus 3V2 is equal to 60. Let's say this is your first equation. Okay, so on applying KCL at this node 2, we can say that, let's say this is your current I3. So it means that at node 2, we can say that I2 plus 5 is equal to I3. So substituting the values of I2 and I3 in this equation, we can say that V1 minus V2 upon 4 plus 5 is equal to V2 upon 2. Okay, so this implies V1 minus 3V2 is equal to minus 20. Let's say this is your second equation. Okay, so from first and second equation, we can say that the values of V1 and V2, so V1 will be equal to 20 volts and V2 will be equal to minus 13.33 volts. Okay, so I hope it is clear how we are solving this particular problem. Okay, so now let's solve another problem based on nodal analysis. So in this problem, we need to find the values of V1, V2 and V3. Okay, so as you can see, let's say the voltage at node 1 is your V1, the voltage at node 2 is your V2, okay, and the voltage at node 3 is your V3, okay. Let's say this is your reference node. It means that the potential at this point will be equal to 0 volts, okay. So on applying nodal analysis at the first node, we can say that, so 3 ampere current will be equal to this current Ix, which is equal to V1 minus V2 upon 2 plus the current flowing from 4 ohm resistor, which is equal to V1 minus V3 upon 4. Okay. So on simplifying it, we are getting 12 is equal to 3V1 minus 2V2 minus V3. Let's say this is your first equation. Okay. So now let's apply at node 2. On applying KCL, we can say that, so V1 minus V2, okay, so the current flowing from 2 ohm resistor, which is your Ix, so V1 minus V2 upon 2 will be equal to V2 minus V3 upon 8 plus the current flowing from 4 ohm resistor, which is your V2 minus 0 upon 4, okay. So on simplifying it, we are getting 4V1 minus 7V2 plus V3 is equal to 0. Let's say this is your second equation, okay. So also we can say that from this, like Ix current, the value of Ix current is equal to V1 minus V2 upon 2, okay. Let's say this is your third equation. So similarly, on applying KCL at node 3, so at node 3, we can say that 2Ix will be equal to the sum of the currents which are flowing from 8 ohm resistor, which is your V2 minus V3 upon 8 plus the current which is flowing from 4 ohm resistor, which is equal to V1 minus V3 upon 4, okay. So on substituting the value of Ix in this equation, we are getting, so 2 Ix is equal to V1 minus V2 upon 2 is equal to V2 minus V3 upon 8 plus V1 minus V3 upon 4, okay. So on simplifying it, we are getting 2V1 minus 3V2 plus V3 is equal to 0. Let's say this is your fourth equation, okay. So using first, second and fourth equations, we can say that, okay, so we can say that the value of V1 will be equal to 4.8 volts, V2 will be equal to 2.4 volts and V3 will be equal to minus 2.4 volts, okay. So I hope it is clear how we are approaching to this solution. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.